I'm going to demonstrate two different ways to approach teaching with storylines in NGSS and phenomena. And the first is going to be perhaps not the best example. Okay, so I want you to be thinking, I'm going to do this fairly quickly. I'm not going to teach to any students or anything like that. Okay, so I want you to be thinking about what are some things that I could do better to be more in line with this way of teaching? Okay, so I'm going to do magnetism, which I believe is first appears in third grade. Okay, so you have 8, 9-year-old students, right? And presumably they are familiar with the idea of a magnet, right? They probably played with them as kids, they have them on their fridge at home, whatever. Okay, so this isn't their very first interaction with them, but it's probably their first time actually thinking about them. Okay. So if I have third grade students, ideally I'd have maybe a set of magnets for every kid. Okay. If that's not possible, maybe we set up, stations or whatever. Okay. But for this, let's just say that I am gonna just show the class. Okay. All right. So I have right here two magnets, okay? And you'll notice that one side is red, one side is blue, okay? And if I want to stick them together like this, I am going to have to pair my red with my blue on each side. And I could do this way, could do this way, okay? I could do like this, okay? But I cannot pair my red and my reds together or my blues together. They will not stick. Okay. There's actually a force. So if I go like this, you can see it pushing the magnet away. And I'm on the blue side there, which I think it just looks silver on the screen. Okay. Okay, so what's happening here with these magnets, these are made of metal, right? There's tiny little electrons, and these electrons are spinning, okay? And some of them spin this way, and some of them spin this way, right? And when you try to put two sides of the magnet together where the electrons are both spinning in the same direction, they repel each other. They don't want to be close to each other. The electrons like to pair up with their opposite. Okay, with electrons that have the opposite spin. Okay, and then if I take these, that's showing up on very well for you guys. Trying to get the glare out. There we go. Okay, so I have some iron filings, and iron is a special type of metal. If I take my magnets, I can get some of them to kind of follow. And in this case, it does not matter what side of the magnet I'm using. Okay. All right. So I'm going to kind of stop there for that example. All right. I did a lot of showing, a lot of telling. I did not preload the students at all. I did not ask about magnets. If you have the resources, you could just have regular play magnets that they'd be more familiar with. Maybe you have them like for your math manipulatives or something else like that. Okay. And I also use terms like electrons, right? Not likely that they're super familiar with that term, if familiar at all. That's a very, very abstract term, okay? And it is the reason why there is magnetism. But the purpose of this, to introduce them, is to just get them thinking, get them excited, and to understand their current conceptions and misconceptions, okay? So what I would do in a real situation is I would probably first start with something like ask a student to maybe come up to the front board, right? And you could just use, again, like objects that you already have. And maybe take, so I have some of these little markers with the magnets on one side, and I have this on one side, like a little clip, okay? And maybe you could ask a couple of them, go hand it to them in their seats. That might even bring a little bit more intrigue. So I'll say like, hey, Braxton and Anna, come on up here. And I'm gonna give you guys these markers, okay? and I want you to tell me some stuff you can do with these markers, okay? And just let them go. Okay, they might say you can take the cap off, you can draw with it, you can erase with it, right? And then I'd be like, okay, like, and what else can we do? Well, we can stick them to the board. Okay. Okay, why? Why can we stick them to the board? What is that called? What else do you know? Okay, what else is a magnet? Do you guys have magnets at home? Okay, so we're going to kind of preload with something that they're familiar with, right? And even better, again, if you can give them some to play with, or if you have those little math magnet boards, anything like that. But of course, you're going to have a whiteboard. Okay, so I would start with that. And then ideally, again, you either have enough of these for everybody, okay, for every single student, or you set up centers. Okay, so some students are going to be in a small group with you exploring this, where they each have their own. So if you have 5 of them, maybe you get 5 students that are with you, and the rest of the class is divided up into 3 other centers. Okay, and they are working independently on activities, right? Ideally, you'd have a parent, but we know that's not super likely. Okay, so all right, so I'm gonna say, let's say I have whole class now. Everybody has these, okay? Let's say, okay, I'm gonna place 2 of these at your desk, okay? And we're gonna do hands in our laps for now, okay? Until I get around to everybody. And what I want you guys to do is we're gonna be respectful of these, of our school supplies, okay? But I want you to play with them. I just want you to see what you can do with them, okay? And then you give them a few minutes to explore, right? Just on their own, kind of, and they may like get with a partner and kind of try to stick it to them, see if they can stick it to different parts of their desk, right? Mine stick to my lab station down here, okay? Maybe they go up to the board and try to stick it. So like let them explore a little bit, okay? And then I would say, okay, what words can we use to describe these? And hopefully they'll say maybe solid, they're hard, they cling together when you hit them, they're red and blue, and they have this letter N on it. And sometimes they stick together, right? They stick to this, they stick to that. I say, okay, so what do you notice about when they stick together? Can you show me how they stick together? Okay. And then we talk about how it has to be opposites, right? Can you find, everybody put them like this, okay? Can you find 2 other ways you can make these stick together? Okay, so maybe they do this or this, you know, a couple different ways, okay? Hold them all up, compare, show the class, okay? And we'll say, okay, awesome. And then, okay, probably an awkward transition there. I had to pause for a moment. Okay, so we're talking about the magnets. Kids got them, right? So while you're giving them some time to explore this, okay, what can they do? You want to pre-plan your questions a little bit. Maybe have some other supplies ready for them. So does it stick to paper? Okay, can you stick 2 of them on either side of the paper? Does it stick? Okay, does the paper interfere with the magnetism, right? Have some other stuff available to them to stick it to. Does it stick to glass? Okay, does it stick to the window? Does it stick to the top of your desk, right? And so you're really trying to get them to investigate, and they've probably had magnets their whole life. But can we now get to thinking about this with like kind of a more critical lens? Okay. When you're going through this, you want to pre-plan your questions, okay? And not in a sense that you're going to be like extremely scripted and rigid, but you definitely want to have an idea of what you want to ask them. And you want to be able to guide them to get to a point, like kind of your end goal for that day, okay, when you're first introducing this. Okay, and then if you have these iron filing boards, which are pretty cool, okay, the idea is that eventually you're going to work up to getting them to see the electromagnetic fields. Okay, so I obviously have to hold it upright, but when you're lying flat, okay, you'll actually have a visual, and then you can put 2 on there and observe what happens when they have the opposite charge. Okay, and then you're going to guide them to kind of thinking about, okay, what's going on here? This is iron. What do we notice about the iron? What kind of material do we think it is? Okay, so ultimately, we're trying to kind of keep in mind our learning goals, right? What are our big ideas of magnetism? Okay, what are we working towards, and how we can we kind of get them to to arrive at some sort of understanding on their own before we actually dive into it and do probably some direct instruction on this, right? We're going to teach the three types of metals that are magnetic. We're going to talk about what it is, probably relate it to Earth's magnetic field, right? Um, and so forth. And so these are pretty cool because they're actually like 3D. I think that's in the screen there for you. So you can see how they're kind of actually reaching up towards the magnet, right? And as you move it around, you can see that it gives them a nice visual, right? Because magnetism is such an abstract idea that this really lets them hold on to it, okay? For us, okay? And so just anything that you can do to kind of bring back, to bring in tangible, relatable experiences. Okay. And then you can keep this going, right? So this becomes then part of your storyline. Okay. Whatever materials that you're using and interacting with, this is what you come back to every day, and you kind of use this as your anchor, right? So if you're talking about the magnetic fields and the positive and negative, when you do it with one, you're actually going to be able to visually see that. And then you can talk about the earth, right? Having two poles. Okay, so you're going to keep kind of coming back to um, these things that you start with, your phenomena. And the more videos are great, and sometimes videos are all that we have, but the more that you can get them to actually just use common products, walk around your room, use the science and the way that they interact with their everyday life, right? Like using everyday common materials, the better and more memorable it's going to be. And it gives them something concrete to anchor these really abstract ideas to. So that's what you're going for here. And when you're actually teaching your lesson, you're going to go through it. I kind of went kind of spotty there and I got interrupted twice. So, a little bit different there, but anything that you can do, supplies you can buy, materials you can put into your budget, and hopefully share with other teachers of your grade level or even different grades because, magnetism is woven in multiple years as well. Um, and it doesn't have to be fancy. Look around your classroom. Okay. Are you magnetic? Does it stick to you? Right? Like I got my safety goggles on still. Does it stick to that? Does it stick to your earrings if you have them in and so forth? Okay. Um, so when you're going through, you want to think about what's something that I can anchor everything to, right? What materials can I use and what questions am I going to ask? Okay. And the students will kind of guide you as well, but you need to have some points laid out. And I used to write them out. Where do you want to start? Okay. How are you going to open up? What's going to be the very first thing that you do? What is this, right? Bring it back to like magnets on a board that they're already interacting with before you bring it to these. Okay. And then pre-plan your questions. Okay. What are some, maybe the 3 to 5 questions or points that you want to make sure you talk about today, to really kind of lay the foundation? And I think it works best if day one is just them interacting with the materials. They're trying to stick stuff. Maybe you have them make a chart, a yes, no chart. Is it magnetic or not, right? And maybe they draw some pictures or they make a graph or something. You can expand the data collection at that point. But day one is simply like explore, ask questions, start to formulate their own ideas a little bit, and then you can really dive in. So hopefully that's helpful.